Hello AP Stats students. This is the first video I've ever done for AP Stats. So we'll see how it goes. It's going to be a little longer than my typical videos because this is AP Stats and I'm going to give you a lot of information. You're watching this as your homework and be prepared with all of this information. Let's talk about types of variables. We have quantitative versus categorical. You should have talked about this already in Algebra 1. If you don't remember or whatever, that's fine. Quantitative takes numerical values for which it makes sense to find an average. Okay, examples of quantitative variables would be like age, right? Most of you are probably 16, 17, 18 years old. Those are numbers. Height. It would make sense to find an average height. IQ score. This is the most common one. We're going to use a lot of quantitative variables. But we're going to use both, and knowing the distinction is going to help you out a lot in this class. Then we have categorical variables, so it places an individual into one of several groups or categories. So examples of this are like color, race, anything that are just groups. So we use color a lot of times, like M&M color. Race turns out to be important. Gender. Tons of different things that we could put here. Okay, so here is a small part of the data set that describes the students in an AP Statistics class. The data comes from anonymous responses to a questionnaire filled out on the first day of class. Okay, so what individuals does this data set describe? Well, the individuals are AP Stats students. One quantitative and one categorical variable. Okay, so a quantitative variable in here would be homework time in minutes, or height, or pocket change, because it would make sense to find the average of those things. So let's just say homework time studied. And the categorical variable would be gender, handedness, pop music, any of those things. So handedness, let's say that. What units are they measured? Well, homework time was in minutes. And handedness was either left or right. Okay, nothing too exciting so far. In the highlighted row, we're going to describe that individual. So that is a female. That is right-handed. She is 58 inches tall. She typically spends 60 minutes on homework. She likes alternative music and has 76 cents in her pocket. There we go. Okay, easy enough. None of that stuff is new or difficult. All right, so now we're going to go in more in depth with this categorical data. Bar graphs and pie charts are for categorical variables. So bar graphs, here's one of the birthdays of students by month. The month with the most students who have a birthday in it is May, and then December. It looks like no one in this class had November birthdays. Okay, very easy. Here's a pie chart. Pie I have eaten. Pie I have not yet eaten. Okay, silly example, but whatever, good enough. So, okay, pie charts, not my favorite. Very few statisticians enjoy pie charts because there's a lot of problems with them. It's very hard to compare when there's a lot of different categories. With bar graphs, you can really, really clearly and easily see which months have the highest, which ones have the least. We get a nice number of students estimate. So this says about 7. This one had about 5. In pie charts, it's really, really hard to do that. It's nice to compare, but that's about it. It's hard to compare different categories. Like this one's very small. It's hard to get numerical values like I was talking about over here, and the total must be 100%. Bar graphs don't necessarily have to have that. Segmented bar graphs are a little nicer. It stacks these categories, especially when you're doing comparing. You have two of these. So you have men and you have women. So you have men who like dance in purple, women who like dance. You can really nicely see that a lot more women prefer dance. TV, you can see that it's more men than women, but they're similar. And then sports is much more men than women. And it gives you a nice little just breakdown. It shows that men prefer sports the most and dance the least. Women prefer dance the most and sports the least. Okay, this is a really nice thing. We'll use segmented bar graphs much later in the course, so we're not going to do too much with them now, but you should know what they're about. Labeling is so important. A huge AP exam error is when the students make these beautiful graphs, but they forget to label and it always deducts the score. So that's going to happen to people. They're going to make these beautiful bar graphs, whatever graphs, they're going to forget to properly label them. So just make sure you're always thinking, make sure you label the title, make sure you label the axes, and do a good job. Take your time. All right. So we have what do teens post? So here are the percentages of 12 to 17-year-olds who post various types of personal information on their social media profiles, according to the Pew Internet Parent Teen Privacy Survey in 2012. You'll notice that Pew is a way that we get data. They're just a survey company. Make a well-labeled bar graph to display the data and describe what you see. Okay, so bar graph, I need some labels. All right, so what I have are the types of information. So, and then I gave them numbers. You can do this, that's fine. And I have the percent who post. So again, if I were to create a label, I would have a title somewhere. I'm just out of space. So what do teens post? Something would be good. For type 1, photo of themselves, we have 91%. Doesn't have to be perfect, but that's good. 2, their school name, 71. 3, their city or town they live in, the same, 71. 4 would be the email address, 53. And 5 would be their cell phone number, much lower. Okay, this is perfectly fine. Then it asks us to describe what you see. So what we see is that they post a photo of themselves much more than they post cell phone number that is the least. Just kind of describing this graph. The school name and city and town they live is about the same, posted about the same. It doesn't necessarily mean the same people posted it. That would be a misconception. And then the email address is lower. And my scale's not great. It should be a little lower, but it's fine. You can kind of see. B, would it be appropriate to make a pie chart for these data? Absolutely not. It has to add up to 100%. You can see that this clearly does not. What we want is we would be looking at a single categorical variable. This one has a lot of overlap. Okay, so Now we're going to get into this marginal versus conditional. This is also a skill from Algebra 1. However, some of you didn't get that in your Algebra 1 because it's kind of a newer sort of thing. But I'm sure you've seen this before, you just don't know the names. So marginal, I want you to think totals. In conditional, based on a set characteristic or condition. So there has to be a condition. It narrows it down from the total. That's how I remember it. The conditional has a condition that narrows it down. Okay, the names aren't quite as important, but they're good to know. So a distribution is when we look at the proportions of all variables affected. Okay, so this is kind of a distribution. So we have cell phones. The Pew Research Center asked a random sample of 2,024 adult cell phone owners from the United States which type of cell phone they own, iPhone, Android, or other, including non-smartphones. So those are my phone types. And here's the results, and they broke it down into age category. And so there's our second variable. So we have this age category variable, and we have the phone type variable. There's two different variables. Okay, we already have the totals in this two-way table, so we're good with that. So now let's answer the questions. Use the cell phone data to calculate the marginal distribution in percent of type of cell phone. Okay, so this is using the totals, right? Because it's marginal. So in part A, we're going to look at iPhone. And the totals are 467 out of 2,024. The Android is 503 out of 2024. And the other is 1054 out of 2024. What we're going to do is we're going to make sure we get a decimal of each. All right, so I have my three percentages now. I divided them. I would recommend that you at least do this one time. Rant number one, everybody who does not do well on the AP test struggles the first half of the school year, and it's because they do not try to do things on their own. The second half of the year, people start knocking it out of the park, but if they would have just done it the entire school year, they would have been fine. And so now you have to make a choice right now. If you want to do well on the AP test, take the extra time to do the calculations. Going to try and preach this a little more often and get some better AP test scores. Not that they're bad, but just they could be a lot better. We need to make these into percentages so we can compare them really nicely. Fractions are hard to compare. In this case, it's not that hard because they're the same denominator. But we can see that other is much higher than iPhones and Androids. And I believe this would have changed a little. This is a little bit old data. So this is the marginal distribution of all types of cell phones. So B, make a graph to display the marginal distribution. I'm just going to do a quick sketch of a bar graph. So I'm going to make a segmented bar graph since you haven't seen that before, part B. So I labeled my scale, I got my percentages and my phone type. The iPhone was 23.7%. So I'm going to do that one first. So I'm going to go up to 23.7-ish. So that's my iPhone. I'll put a little legend. Then I have another 24.9 Android, slightly larger than that. Okay, so 24 would get us up to about 50-ish. Again, doesn't have to be perfect. We're doing this for comparing reasons, remember? So in my legend, I have Android. And then my other. The rest of the phone users were other. All right, so there's a segmented bar graph. Not too difficult there. That was part B. Part C, use the cell phone data to calculate the conditional distribution of cell phone type for the 18 to 34-year-olds. Okay, so there's our condition. The condition is the 18 to 34-year-olds. So what we're going to do is we're only looking in that category. So if we look at the iPhones for the 18 to 34-year-olds, we have 169 out of 517. For the Androids, it is 214 out of 517. And for our other, it's 134 out of 517. And then again, you should use your calculator right now to actually do this. Okay, so now that I have my percentages, it would be easier for me to compare. 32.3 compared to 41% is a little less iPhone usage out of those 18 to 34-year-olds. And they both beat out other. Even though the other category was way higher, remember it was that 51% in that age category, other was way lower. So if we think about this in part D, is there an association between type of phone and age? There is. It appears, based off of this conditional distribution, that there are many more iPhone users that are 18 to 34 and even more Android users that are 18 to 34. So there is an association. It means that these younger people are using iPhone and Androids much more than other phones. And as age gets older, it seems that the distributions are changing. So yes, there is an association between phone and age. Okay, we didn't rigorously prove that, but we created an argument. So you can't just say yes. You need to explain, like I just explained. Yes, because, and then what we just said. Okay?